here we go. Okay, so hi everyone. My name is Danielle Blunt. I use she, her pronouns. I'm with Hacking Hustling, which is a collective of sex workers and accomplices working at the intersection of tech and social justice to interrupt state surveillance and violence that's facilitated by technology. I just wanted to share a few housekeeping things. I will be monitoring the Q&A. If any and all questions could be put there, I will, Olivia and I will be helping to look at those. And if anyone wants closed captionings turned on, you can go ahead and you can either click the closed captioning button and say turn on or off, whatever works for you. And I'll type that into the chat in a second when I'm done as well. And I wanted to just start off with a few values and shared agreements and intentions before we begin. We believe that sex work is a valid form of labor, that our vulnerabilities are the result of sociocultural approach to transactional sex. We believe in the decriminalization, decarceration, and divestment from state violence. We believe in access to more opportunities, not less, that is the path to harm reduction and safety. Sex workers who use internet platforms are part of the larger world of people who engage in commercial sex, and we value all forms of transactional sex. And so starting from that place, I'm going to mute myself and pass it along, and just to the panelists, if I see anything in the chat or anything asking folks to slow down, I'll just unmute myself. So go ahead, take it away.
Hi everyone. Just before we begin, some of the values that we're trying to center this workshop in terms of cyber defense is firstly acknowledging cyber defense as a way of accumulating community-based power and cryptography as an abolitionist technology, rather than thinking of it as like military technology or something that doesn't come from us, right? So acknowledging that there have been ways of using techniques like cryptography and that community defense is something that doesn't have to be immediately associated with like a white supremacist technology, like industrial complex, that these are things that also come from us. And so following that, we really want to affirm that there can be a cyber defense pedagogy that is anti-racist and anti-binary and pro-femme, but also one that's trauma-informed, right, and doesn't reinforce institutions of paranoia, because we know those to be white supremacist institutions, and really teaching from a place of gentleness, and also considering, because of our myriad of identities, the previous digital harm that people might have experienced, and not trying to replicate it or force people to relive it. So if you need to take some space at any point during this workshop, we really honor that, and this will be recorded and available for view at a later time as well.
Thank you, Olivia. That was great. My name is Ingrid. I go by she, her pronouns. And we are, welcome to the internet. This is the first of a series of 3 digital literacy sessions where we're gonna be walking through a few different concepts. And this first one we wanted to start with was really getting into just some of the baseline, technical things around what the internet actually is and how people experience it, or how it, works. And we've sort of organized this into a couple sections. We're gonna, start kind of with a couple of things about our personal kind of opinions about how to talk about some of these things, and some grounding perspectives we're bringing to it. The internet and kind of how it works as an infrastructure, browsers, which as like a particular technology for interfacing with the internet, and the World Wide Web, which is, basically the thing that the browser takes you to. So starting with our opinions, we got more, but these seem important to start with. The first one that we wanted to convey is that, you know, that some of this stuff around how the internet works gets treated like this sort of special knowledge or like something only for smart people. But, you know, companies have a lot more resources to do things. The people who found tech companies often have had, you know, privileges like generational wealth or like early exposure to technology that mean that some of this stuff was just more available to them and has been for a long time. And if there are things that are confusing or unfamiliar, it's you know, it is not because you don't understand, and it's because the people who kind of have a lot of control and power like are able to like overcome things that are confusing. Yeah, we'll come back to this point in other ways, I think, in the presentation today.
The other point that we really want to hammer in is that nothing is completely secure online, and that's due to the nature of how we connect to the internet, right? The only way you can really have a completely secured computer is to have a really, really boring computer, right? Computers are interesting because computers and the internet are able to be interesting and fun things to use, and because we are able to connect to other computers, right? Because it's a form of like telecommunications device. And so it's kind of okay that our computers can't be completely secure, because if they were, they'd just be kind of like brick boxes that don't really do anything. So instead of trying to chase like a mythological like security purity, what we do is we learn to manage risk instead, right? We create systems so that we put ourselves in at least danger as possible. Yeah.
So for our kind of initial kind of grounding point, we want to just start with what the internet is. And this is a hard question sometimes, I find, because the word internet comes to kind of mean lots of different things. For me, one of the most like the simplest summary I can ever provide is that the internet is just computers talking to computers. It's information going between computers. This image, which is, you know, one of many you can find when you Google image search, internet diagram, is a bunch of computers in, you know, a household, including a game machine and a few PCs. Who is this person with all these devices? And they're connecting to a router in their house, which has connected to a modem, which connects to the internet, which is more computers, not the ones that you're seeing on the screen. This is kind of dorky, but this is a really goofy example of a computer talking to another computer. It's from the movie Terminator 3. This also, I realize, is an Italian dub.
Connessione. Distretto scolastico di Los Angeles.
So I showed this. So what's actually happening in this scene, which is, yes, very garbled, is the lady Terminator, who is a robot, a very large sentient computer, is using a cell phone, like a dumb phone, to call another computer. And then she is making noises into the phone that are a translation of data into audio signal. And that is allowing her to hack into the LA school district's database. It's very 2003 in that was an era where when people were getting online in their homes, they would have to, connect to a modem that would make sounds like that too. So I think it's kind of a corny old example, but I like it because it also shows something that is often hard to see in our day-to-day use of the internet, which is that for information to move from one computer to another computer, it has to be rendered into something material. In this case, it's tones, it's sound. On a home computer connected to a Wi-Fi network, it would be radio waves. And in kind of when you get to different layers of the internet, it's going to be pulses of light traveling through fiber optic cable. So everything you type, every image you post at some point it gets, that digital data gets transformed into a collection of, arrangements of points of light, or, a sound, or like a different material. And it's, it's much bigger than what we see on a screen. This is a map of the submarine cables that cross oceans that make it possible for the internet to be a global experience. It's very terrestrial. This is just for fun. This is just a video of a shark trying to eat one of the cables in the ocean. This is a cutie. I just love his little. And then he changes his mind. The point being, the internet is vulnerable to sharks. It is very big, and it is complicated, and it is not just, a thing on a screen. It needs a lot of physical stuff. And when computers talk to computers, that doesn't usually mean like a one-to-one connection, right? So I'm talking in this webinar to all of you right now, but like my computer is not directly connecting to your computer. What's actually happening is that both of our computers are talking to the same computer somewhere else. There's like a intermediary machine that's probably in a big building like this. This is an Amazon data center in Ashburn, Virginia. And that's a kind of the model that most of the internet takes. It's usually kind of, there's intermediary platforms, right? And in a lot of technical language, this is called the client-server model. The idea being that a server, which is a computer, holds things that are, content on the internet or applications like Zoom, and the client, which is just a computer, requests things from the server, and the server serves that. This gets to the client computer through a routing process that usually means that the information has to travel through multiple computers. But again, these words just mean computer and computer. Technically, you could turn a home computer into a server and give it a stable internet connection and make it something that just serves information at the internet. Or, you could even think about the fact that because, lots of information is taken from personal computers and sent to companies, in some ways, we are serving all of the time. And I mostly this is just a dynamic, again, thinking about who controls and how the internet is governed that I think is important to acknowledge. I mean, in some ways, the internet is not computers talking to computers so much as computers owned by companies talking to computers owned by people. And the internet, it began as a project funded by the US military, but became the domain of private companies in the late 1990s. So all of that stuff that I was talking about earlier, the submarine cables, the data centers, they're all private property owned by corporations. And it's kind of all of the, technical infrastructure that makes the internet possible is a public good, but it's all managed by private companies. So it's more, a neoliberal public-private partnership, and it has been for a very long time. And I mentioned this mainly because it's good to remember that companies are beholden to laws and markets, and it's in a company's interest to be compliant with laws and be risk averse, and that's partly why a lot of decisions made by platforms or other companies are often can be harmful to communities like sex workers. And again, this doesn't have to be the way the internet is. It is sort of how it has been for a very long time. Let's see, what's our next? So computers talking to other computers is what, is our very simple summary of what the internet is. But computers can talk to each other in different kind of languages or dialects, let's say, which in, internet speak are called protocols, which, a protocol is what it sounds like. It's a set of rules about how something's done. And so I find maybe the dialect or language thing kind of useful. So a few protocols that exist for the internet that you probably encounter in your day-to-day life that maybe don't think that much about are internet protocol, Wi-Fi, the address resolution protocol, simple mail transfer protocol, and hypertext transfer protocol. Maybe you haven't heard of as much, or it's not as commonly talked about, but I'll explain a little more about these. And I apologize, my screenshots are from my Mac, so there are ways to access these same sorts of interfaces on Windows machines that I don't have images of. So the internet protocol is basically, that is the foundation of getting on the internet. And it assigns a number called an IP address, internet protocol address, to a computer when it's connected to a network. And that is the ID that is used for understanding like who a computer is and how you access it. So when I want to go get content from a specific website, what I'm actually requesting under the hood is a set of numbers that is an IP address, which is where, like, the name or ID of the computer that I want to go to. I'm hoping this isn't too abstract, and I hope, like, yeah, please, if there's places where you have questions, please add things to the Q&A. So address resolution protocol and media access control are a little different, but I wanted to talk about because it's sort of related to understanding how your computer becomes a particular identity. So there's a question, do all computers have their own IP address? They do, but they change because basically when you join the network, the address is assigned. It's not a fixed ID. But there is a fixed ID that is connected to your computer, and it's called a media access control, or MAC address. And this is another sort of screenshot from my machine. You can see this thing I've circled here. That is my MAC address. And that is at the level of like the hardware of my computers, an ID that has been basically like baked into the machine. Everything that can connect to a network has one of these IDs. And so address resolution protocol is a mechanism for associating your temporary IP address with a MAC address. And it mainly exists so that if the network screws up and like assigns the same IP address to two things, to like two different devices, the MAC address can help resolve like, oh, we actually mean this device, not that device. Oh, I realized I didn't make a slide for Wi-Fi. I think most of you probably know Wi-Fi as like it is the wireless, the way that basically information is transferred to something wireless. Yes, your IP address will change when you connect, although it generally won't change that much. It's not like, how am I answering this? Like if you're connecting to the internet at like your home, you're probably gonna get the same ID number just because it's the same, device you're connecting to. But when you connect to a network I guess no one goes to coffee shops anymore, but in the time when you would go to a place with a different wireless network and connect to the internet, you would probably have a different IP address because you're connecting from a different device and a different network. Does that make sense? I hope so. Okay. Yes, fantastic. Oh, the only other thing about Wi-Fi I will mention right now is that Wi-Fi doesn't actually mean anything. It's not an acronym. It's not an abbreviation. It's a completely made up name. No one has a good answer for why it's named that. I think like a branding consultant named it. It's anyway. So other protocols. So the simple mail transfer protocol, that underlies how email works. So you encounter it a lot, but probably don't think much about what, like that's its own special kind of language that's used for moving information that's different from the hypertext transfer protocol, which is one that may be familiar to all of you because it is the central protocol used for moving information in the browser, which is a nice segue, but I realized I also should mention that there is a variant of HTTP called Hypertext Transfer Protocol Secure, or HTTPS. And it's an implementation of HTTP that encrypts the information that is being transferred. That wasn't adopted or implemented when browsers and HTTP were first being developed, because again, these technologies were being developed with public funding and thought of as tools for scientific research, not for making purchases with credit cards or having private communications. So the implementation of security features and encryption into the internet is sometimes clumsy or frustrating because it was not designed into the original concept. All right, so we're next moving into the browser. I'm kind of a nerd about internet history things, so part of what I wanted to talk about with the browser is some of just its origin story. So the first kind of version of a browser that was kind of considered like easy to use and became popular was created in 1983 by some computer science researchers at the University of Illinois, including a guy named Mark Andreessen. Mark Andreessen went to Silicon Valley and used the technology underlying the browser he had worked on in Illinois to create a company called Netscape. Netscape Navigator was kind of it was a very important opening of the internet to a general public, and it changed a lot of the people's perceptions and like ability to be part of the internet. Mark Andreessen became very rich because he did this, and he founded a venture capital company or venture capital firm called Andreessen Horowitz. And again, just returning to this idea that a lot of tech companies are not smart, they're just rich. Mark Andreessen worked with a team on a thing that was really important. That is not a good reason that he gets to throw money at Airbnb and decide how urban planning and housing is going to be fundamentally changed forever. There are fundamental kind of reason, like there is something about that which I feel like is always important to remember. Both to acknowledge like Mark Andreessen. It's not that Mark Andreessen is a dumb guy. It's that he has been given a lot of authority through getting a lot of money through being part of a clever thing. Eat the rich. A lot of the things that defined the browser in the 1990s when it was first kind of becoming a commonly adopted thing were actually proprietary technologies made by different companies. So different companies had their own browsers that they had made, and they wanted to be the browser everyone used, right? And so they invented new things to make their browser cool, but they wouldn't work on other ones. So Olivia will talk a little bit more about these, I think, in the section on the web, but cascading style sheets, which is a way of adding, like designing aspects of a web page, were actually invented by Microsoft. JavaScript, which is a programming language that works in browsers, was created by a guy at Netscape in 14 days. And yeah, if you made a website and it had CSS in its layout, it would be visible in a Microsoft browser, but not in a Netscape browser. This was a terrible way of doing things, and partly because companies got nervous about possibly getting regulated, and partly because it was just bad for business. They figured out how to kind of put aside some of their differences and develop standards, basically. So the standardization of browsers, so that basically when I open something in Chrome and I open something in Firefox, it looks the same and it works in the same, kind of starts to be worked on in 1998. It really only starts to be implemented widespread in 2007, and it's continues to be worked on. There are entire kind of committees of people who mostly work at the tech companies that make these browsers, who kind of come and talk to each other about like what are the like things we're all going to agree about, like in terms of how this technology works. And we're looking at and wanting to talk a little bit about browsers also because they are really useful teaching tools. It's really easy. Well, it's not really. It is pretty easy to kind of look at what's going on behind the scenes using a browser. And that's mainly because they're very old. You know, by 2007, when the iPhone emerges and when I think the App Store is 2010, 2011, you can't really like see, like it's much harder to go on your phone and see like, I wonder what kind of data Instagram is sending back to, you know, Facebook right now. Like to actually try and look for that on your phone is almost impossible, but you can kind of start to look for that in a web browser. And that's sort of a privileging of desktop technology and a legacy of this being kind of an old technology where transparency was treated as just inherently a good idea. And I think if they were being built today, we probably wouldn't have it. So we're going to introduce you to some browser tools in this next section. Oh, wait, sorry, there was one more thing I wanted to acknowledge. This isn't super detailed as far as kind of comparing the privacy features of different browsers, but we are working on a list of sort of like a bibliography that we can share with everyone later. The main thing I just wanted to convey here is like different browsers designed by different companies. They're gonna all work more or less the same, but they do have kind of underlying qualities that might not be great for user privacy. And also there's, you know, questions of like when, you know, one company kind of controls the browser market, how does that change kind of the way that people see the internet? So, you know, doing some research, doing some comparison of what different browsers, you know, do and don't do. Most of the screenshots for this were done in Firefox. If you use other browsers, that's fine. But yeah, all right. Now we will move to the World Wide Web.
Hi, everyone. So this part is talking a lot about the actual content that you are able to look at using your browser. So we'll be making use of a lot of the tools that Ingrid mentioned about looking deeper into the actual web pages themselves. Yeah, awesome. So this is a web page. It's the same page that the video that we showed early in the beginning of sharks biting the undersea cables. And it's accessible to anyone who can connect their computer to the World Wide Web. And so a lot of times we use the internet and the web interchangeably, but the internet itself is more of the infrastructure, and the actual place, if we can call it a place, that we're going to logically is called the World Wide Web, right? That's the whole www dot thing that we've all been doing. So web pages are hosted on computers. You can host a web page on your own computer. You can pay another company to host it for you. Other companies host it themselves if they have a lot of money. And if you are paying someone else to host website for you, you might end up, you have a lot less autonomy, right? So there's a lot of movements for people to like start hosting things themselves to avoid things like censorship and surveillance, because like we said at the beginning, companies are beholden to a lot stricter laws than individuals are. And individuals are able to kind of themselves say, what's the difference between a VPN and Tor? If we have time in the end, we will cover that a little bit briefly. But essentially a VPN, Tor is a browser, and a VPN is something that you can install into your computer. Tor does things that are very similar to what VPNs do in terms of like onion routing, but they're not the same. Like you can use Tor to navigate the internet, or you can use a VPN and use your normal browser, right? So can you go to the next slide? Awesome. And so to look at a web page's source, right, oftentimes you can right click or command click, and click the like view page source. Thank you for the mouse. Or you can click view page info, but that will that's the wrong browser. You would click view page source, and you'd be able to get a closer look at the actual web page itself. And so when you view the source, you can go back. When you view the source, you end up seeing HTML, right? So we told you earlier that the web uses HTTP, which is a hypertext transfer protocol to send and receive data. The data that's being sent and received is hypertext, right? That's written in a hypertext markup language. So HTML isn't a programming language per se, it's a markup language. So it defines the structure of your content. It displays things like text and images and links to other web pages. And there are two ways that HTML pages can exist, static and dynamic. So static would be a lot of the pages that we might code ourselves, right? Dynamic is more of the web pages that are generated dynamically are like Facebook and Instagram. The user requests a page, which triggers code that generates an HTML page. So sometimes you would want to, if you try to look at the source code of a website, you won't really see much of anything because that code like doesn't exist yet. Unless you open an inspector and you look at the code that's visible on your side. So to make this content look better, it's often styled, right? Because otherwise it would just be plain Arial size 12. So we add color, we add shape, we create layouts, we make things bold and italic, and we do that using cascading style sheets or CSS. This is also another form of displaying, right? So CSS is also not a programming language. It's a way of like representing information. So this is what a static HTML file might look like. I grabbed this from a teaching resource, so that's why you can see things like explanation of what HTML is, because I thought it would look a bit cleaner than the Wired article. And this is a CSS file. You see things like font size, font family, color, background color, position, right? So those are the types of things that you can control using CSS. You can even make animations. So knowing that, the point that we're trying to make in saying this is that HTML can't do anything with your data. Neither can CSS. They just display things that are coming from the other computer that you're connecting to. So how are web pages collecting our data? Well, the code that actually does stuff in your browser is usually written in JavaScript. So To see it in action, we can go into Tools and Web Developer in the Inspector. And we can see some of the stuff that's going on behind the scenes, right? This is how you do this in Firefox. And it's similar, but not identical in other browsers like Chrome and Safari. I don't think you can do this in Safari at all, but I might be wrong about that. So if we check out the Inspector tab, we have an easier way of reading the HTML source than just like pulling up the source in a really large, confusing doc, right? We get syntax highlighting, we get little disclosure triangles, and we're able to highlight things and see, we're able to hover over different parts of the HTML and it'll highlight that section in the actual web page. So it's really a useful teaching tool. The console tab, we're able to see more of the JavaScript activity that's happening in the background of the page. So we're able to see all of these like jQuery calls and database calls and analytics, right? So this is how a web page might try to get information about you so that the company, in this case Wired, can use that information to structure their own marketing practices. Like how many people went to this article about sharks biting undersea cables? They would use JavaScript in order to record the fact that you, one person, went to this website. In the network tab, it shows data being sent and data being received by your browser, right? So all of the ones marked post, or you can only see the PO in this part, are being sent, and all the ones marked get are being received. And so some of this stuff is fairly like normal. It's actual HTML stuff that's being included on the page. You can see the different types. And then some of it, in other places, you be able to see like actual trackers, right? And when you click on one of the items, you're able to see more information about what's being transferred.
And this is not necessary. I mean, although this is not very helpful, like just when you click on the headers, like it's like, here's a bunch of words. I don't know what's going on. But the other tabs can give us a little more, and depending on the type of network request, you'll get slightly easier to read data. So in this section, we're going to talk a little bit about some of the tracking methods. Cookies are called cookies because they're called cookies with the web because in a different technology whose name I do not recall, this same thing was called a magic cookie. And I don't know why it was called that in the other one. It's a holdover from the fact that a small number of people working on the internet had inside jokes, as far as I can tell. But a cookie is a text file that contains information. Usually it's something like an ID. And it's used for doing things like storing preferences or kind of managing things like paywalls on news websites. So in this case, the cookie that was handed off to me from this particular page gave me this ID number that's just like a pile of letters and numbers. And my browser will store that cookie. And then if I go back to Wired's website, it'll check to see like, oh, do I already have a cookie assigned to this one? And if it does, it will take note of how many other Wired articles I've already read. And that's how Wired is able to say, hey, we noticed you've read all your free articles. Stop doing that. You don't get any more. And they're not, and they can also be used for things like, let's say you have, certain kind of like you have like a login with a particular, website, and you don't want to have to log in every time, and the cookie can store some information for you. but they're also used for things like kind of track, like kind of just trying to see where people go online to, you know, be able to figure out how to sell them things. Just a distinction note, like if you look at things in the network tab, like a response cookie is a file that comes from like a website to your computer. A request cookie is a file that your computer generates that goes to that computer. And it's, you know, and a lot of this is stuff that is encrypted or encoded or like kind of like stuff, which is good insofar as like it's not creating, oh, sorry. It's not just giving, you know, information, passing information about you and storing it in the clear. You still probably don't want them to have it. So cookies also can be used for, you know, tracking. They're like, this website, you know, has like a lot of different scripts running on it because, you know, media companies work with other, you know, companies that do this kind of audience tracking stuff. So like when I was looking at this one, it's like the URL that the domain it was coming from is elsa.memoinsights.com. I was like, that's a weird name, and I don't know what any of this is. Elsa.memoinsights.com. If I type that into the browser, it doesn't produce a web page. But when I Google Memo Insights, I find a company that works with publishers to give them, you know, competitive analysis and campaign summaries. I don't know what these things are exactly, but this is some boutique analytics company that works with Condé Nast, which owns Wired. And maybe they do something like they pay attention to what other Condé Nast properties do I read? And what can we learn from the fact that people who read Wired also read The New Yorker or something? There are other kinds of tracking methods used on the web that are not based in cookies and are a little bit weirder. So pixel trackers are basically just tiny image files. They're called this because, you know, sometimes they're literally just 1 pixel by 1 pixel. And to load the image, you know, the image is hosted on a server somewhere else, not on the Wired website. It's hosted by whatever company, you know, is doing this work. And because the image has to load from this other server, my computer makes a request to that server. And once that request is logged, that's you know, that server can, you know, get information from my request about, you know, my computer, where I'm coming from, how long I spent on it, what time I accessed to the thing. If you've ever used like email marketing software or like newsletter software, like MailChimp or TinyLetter, this is usually how those services are able to tell you how many people have opened your email. They'll have like an invisible pixel tracker loaded into the actual email, and will send the information about when that image loaded to the newsletter service. So pixel trackers, they're sort of sneaky in that they're like, again, like you literally can't see them on the web page, and they're not as transparently kind of present on the things. Another method of tracking users on the internet across different websites is something called browser fingerprinting, which is a bit more sophisticated than cookies. So in the last few years, browsers have become a lot more dependent on and intertwined with a computer's like operating system and hardware. For example, when you join a Google Hangout or a Zoom call, the browser is going to need to access your webcam and your microphone, right? And those are like, you know, parts of the hardware. There needs to be like ways for the browser to talk to those parts of your computer. And that in and of itself isn't a bad thing. but it means that if if some code is triggered that asks questions about, those other parts of hardware, it might just get up, like that's data that could get sent to another server. So in this example, we're looking at the loaded information includes things like browser name, browser version, and that stuff, like that will usually be in a typical like request, like knowing what the browser is or what kind of browser isn't that unusual. But then we get things like, what operating system am I on? What version of the operating system am I on? I don't know why this site needs that information. I didn't see any fingerprinting happening on the Wired website, so I had to go to the YouTube page that the video was on. There are a lot more detailed sorts of things that can be like pulled into fingerprinting. So like your camera, like is your camera on? What kind of camera is it? That can be something that a browser fingerprint will want to collect. Your battery percentage, weirdly, and all of this is in the service of creating like an ID to associate with you that is definitively your computer, basically. As opposed to like, you can actually like erase cookies from your browser if you want to, or you can say like, don't store cookies. But it's a lot harder to not have a battery. In terms of knowing if fingerprinting is happening, one way to do that in the network tab is you're looking for the post requests, which means that your computer is sending something to another computer. And one way that it can get sent is in a format called JSON, which is an abbreviation for JavaScript Object Notation, which is basically a format for data that can be processed by the programming language that works in the browser. This is another way if the network tab is like a little overwhelming. There are browser extensions that can show you more kind of detailed things about what's going on with fingerprinting. Additionally, just as a side note, the fact that browser extensions are another example of like throwbacks of the browser. The idea that anyone can build like extra software for that piece of software it's like no one would ever let you do that to the Instagram app on your phone. And it's sort of it's a kind of a leftover thing from something like Firefox started doing it in 2004 and then everyone copied them. But back to fingerprinting, just as far as this is a Chrome extension called DFPM, Don't Fingerprint Me, that just logs this in a slightly tidier way. So I thought I would show it. And it highlights a couple of examples of ways that this page is currently doing fingerprinting that I might want to know about. So canvas fingerprinting is a method. It sort of describes it here. It draws like a little hidden image on the page that then is kind of encoded to be like your fingerprint. I think Firefox actually blocks this by default, so I had to do this. WebRTC, that's related to your camera and microphone. WebRTC stands Web Real-Time Communication or Web Real-Time Chat. I'm not sure which. But that's basically the tool used for doing web calls. They'll also look at what fonts you have on your computer, your screen resolution. You can see here the battery level stuff. So I guess the point I wanted to bring across with the fingerprinting stuff is just that like there are lots of different things in play here. Do you think we have time for our bonus round? It's almost 1, but I feel like I think there was some interest in this. I don't know, Olivia, what do you think?
I just pasted in the chat an answer to the Tor versus VPN question, so we can skip those slides. But it might be useful to kind of rapid fire go through safer browsing techniques. Yeah, I just got a yes please in the Q&A, so I think we should go through it.
All right, so quick version of the VPN thing. this is how a normal internet connection, collects, logs data about you. So I go to a website and it logs like this computer came to me, this computer over here. A VPN basically means that you're connecting to that computer through another computer. And so your request looks as though it's coming from kind of somewhere else. That being said, like it's, there's still other data, like given the point I just made about fingerprinting, there's other data that could be collected there that's worth kind of thinking about. When data travels through Tor, Tor is an acronym for the onion router, and the idea is that it sort of wraps your request by going through multiple different computers, which are called relays. So when you use Tor, which is a browser, and to connect, it sends your request through this computer and this computer and this computer, and whatever is the last one you were on, like before you get to the page you want to visit, that's where that's the IP address that this device is going to log. These are called this last sort of like hop in the routing is called the exit relay. Those can be yeah. I think that was my attempt at being quick. I apologize.
Fun fact about VPNs, if you, because the United States has different privacy laws than other countries, if you were to connect to a VPN server that was in, for example, the European Union, you might get a lot more notifications from the sites that you normally go to about different cookies and different things that they do with your data, because in Europe, they're required to tell you, and in America, they're not always required to tell you what they're doing with your data. I can take it. So this is how, in Firefox, you would open a private window. In private windows, I think we're all kind of a little bit familiar with them. They clear your search and browsing history once you quit. And it doesn't make you anonymous to websites or to your internet service provider. It just keeps it private from anyone else, but that might be really useful to you if you are using a public computer, or if you're using a computer that might be compromised for any other reason, like say if you suspect that you're going to a protest and a cop might take your device from you at any moment. Do you want to read at the end? Yeah, I can try and read that out.
So script blocking. So we had mentioned that a lot of the tracking, like things like the fingerprinting or the the addition of little, analytics tools and stuff, usually are written in JavaScript, because that is the only programming language that works in a browser. So there are tools that will prevent JavaScript from running in your browser. And that can be helpful for preventing some of those tracking tools from sending data back to some, computer somewhere else. It can be a little bit frustrating because JavaScript is used for all sorts of things on websites. Sometimes it's used for loading all of the content of the web page. Sometimes it's used to, make things like kind of have like fun UI. But it's sort of, it's interesting to try, if only to see how much of your internet experience needs JavaScript. But yeah, there are some tools that will, so there's the Electronic Frontier Foundation has a browser extension called Privacy Badger that sort of learns which scripts are trackers and which ones aren't as you browse. But yeah, these are extensions that browsers you can install onto a browser. And firewalls.
So firewalls are kind of the first line of defense for your computer security. It would prevent basically other computers from connecting directly to your computer unless you say yes or no. And so they're really easy to turn on your computers, but they're not that way by default. So in a Mac computer, like I've shown here, you would literally just go to security and privacy and go to the firewall tab, and it's like one button, turn off or turn on. And you don't really have to do much more than that. And in Windows, there's a similar process. If you go to the next slide, where you really just go into settings, go into security, and switch the on setting. It's pretty easy, and it's kind of annoying that it's not done for you automatically. But I recommend everyone to just check out and see, like, hey, is my firewall turned on? Because it's a really easy step to immediately make your computer much safer.
Oh, that's it. All right. We went through all the slides.
That was perfectly timed. You you got it exactly at 1.
Should I read the Tor versus VPN answer?
Yeah, that would be awesome. And then I think if folks want to start entering questions into the chat about anything that they could use further clarity on or anything like that, we can see if we have time to get to those.
Okay, so for the Tor versus VPN answer, as we said just a while ago, Tor uses onion routing and sends your data through multiple computers called Tor nodes to obscure your traffic and anonymize you, while a VPN just connects you to a VPN server that are often owned by VPN providers, which is why sometimes you have to pay to use them and the other ones are free. I described it as kind of like a condom between you and your internet service provider. So Verizon knows that you're using a VPN, but it doesn't know what you're doing on it because a VPN would encrypt all your traffic. It's really important that you use a VPN that you trust because all of your internet traffic is being routed through their computer, which is another reason why people like to pay, because you can have a little bit more faith that it's like a trusted service if you're paying for it, even though that's of course not always true. But there is a Proton VPN, which is one that I use that's free, that's run by the same people who run Proton Mail, which is an encrypted email service, and that's one that I think is pretty trustworthy. I haven't had any problems with it. You can use a VPN and Tor at the same time, which is what the question directly asked. And I believe that your ISP would know that you're using a VPN, but because you're using a VPN, it wouldn't know that you're using Tor. Ingrid, if that's not true, you can like clap me on that. Because Tor is super slow and it routes your computer through a bunch of different things, it can break a lot of websites, including a lot of video streaming services like YouTube and Netflix. A lot of people use VPNs, however, so that they can watch Netflix or use other sites that are banned in particular countries by making their computer look like it's from a different place. But if you're doing something that's highly sensitive or potentially illegal, you'd probably want to use Tor and probably some other precautions too.
Thank you so much. That was super helpful. Do folks have any questions? Is there anything that people would benefit from sort of like going back and going into in a little bit more detail? So, okay, so we have one question that says, I'm a sex worker who's involved with some organizing work with other sex workers. I was wondering if it would be okay if I took notes and summarized this workshop. Yeah, I'll answer that one. This one will be live, so you can just send them a YouTube link in a couple hours once it's up. Thank you for asking. And then someone just said, is there a way around Tor breaking websites? I've used it and it throws a lot of CAPTCHA tests on regular websites.
So Cloudflare kind of hates Tor. Like it takes a really aggressive stance towards Tor users actually. Like there was like an Ars Technica article that I read that basically said, Cloudflare said that 94% of Tor traffic that we see is per se malicious, right? So you actually, I don't think there's going to be a time soon where you'll be able to use CAPTCHA and have it not freak out, because Cloudflare sees that kind of activity as like malicious activity.
This may be hardware related, but does Apple see what you're doing on your computer because you connect to the internet, e.g. any photos, videos you store? Okay, to make sure I understand the question, is the question whether like if you're using an Apple device, whether Apple is like able to see or collect anything if you're connected to the internet from that device. Okay, so I mean, the answer to that is you would need to kind of tell them to do that. So like if you are using something like iCloud to store photos and videos, then yes, they would be able to see and have all of those. But in terms of like just being on the internet doing things on an Apple device, Apple can't personally like kind of peek in and see that. I mean, they like there, you know, other computers will know like that you are on an Apple device, but yeah, you'd have to be directly interfacing with Apple's network for Apple to be able to have anything on or from your computer.
And when it comes to things like iMessage and iCloud, they say that information is encrypted. Of course, it's like not open source, so we don't actually know how they're encrypting it or what they do. But Apple has said for a while that communications between, like, say, two iMessage users, so not someone who's using iMessage to speak with someone who has an Android, that's SMS, but two iMessage users who are speaking to each other, that's technically an end-to-end encrypted conversation. Apple does collect some information from you when you are initially typing in someone's number to text them, because it pings the server to find out if that number is associated with an iCloud account. So that little moment for iPhone users, that little moment between when a number that you're typing in turns either blue or green, in that moment, it's sort of pinging Apple's servers. So they do have a list of the times that ping has occurred. But of course, that doesn't tell you if you actually contacted the person whose number you typed in. It just knows that you made that query. And that's the extent, so Apple says, of the information that they collect about your iMessage conversations. So yes, they do. They can technically see that information, but they tell us that they don't look at it. So.
Can you explain a little bit more about open source versus closed source technologies?
Yeah, so open source technologies are basically they're apps, websites, tools that the code that's used to like write them and run them is publicly available. When it comes to security technologies, it's really best practice to try to use tools that are open source, because that means that they're able to be publicly audited. So like regular security experts can like go in and like actually perform an audit on open source security tools and know that they work, versus you have a lot of paid security tools that you basically assume that they work because the people tell you that they work. And you can't really the public can't really hold them to any like public accountability for whether or not they work or not, versus you can actually like test the encryption algorithm, say, of Signal, which is a messaging app, and all of their code is public information.
Yeah, and open source, it's also like a way of kind of letting people developing software kind of support each other in a way, like, because the fact that Signal is open source means like it's not just like, oh, we can be accountable if like, you know, Signal says it's doing something but it's not doing something. It's also a way to say like, hey, I noticed something isn't working, and like kind of like you can actually like directly contribute to improving that technology. It's complicated. I mean, the world of open source is complicated in that it's like it still has elements of the like, you know, snobby like culture of tech sometimes, but in its like kind of in principle, it's very like useful for being able to have technologies that are accountable and that kind of have some element of like public engagement and understanding.
Awesome, thank you. And so I have another question in the chat. What are some good ways to assess the trustworthiness of a VPN, as you were discussing before?
The way most people do it, I think, Ingrid, you could check me on this, is kind of by reputation. If you look up like how to pick a good VPN, You'll find a lot of articles where people talk about the pros and cons of different ones, and you'll also probably be directed to the ones that are considered by the public to be the most trustworthy ones.
Yeah, and I think, I mean, one way that I guess I evaluate companies sometimes on this is like looking at their level of engagement with the actual like issues that they of like user privacy. So like one of the, you know, things that I ended up using as a reference for this workshop as a guide to as a guide for like different browsers was like a blog post by ExpressVPN. Like, and they're a company that they don't have to tell me anything about like which browser, like there's no reason for them to generate that content. I mean, I guess it's good PR-ish, but like they're not going to get new customers because I'm using a different browser now, right? So some of it's looking at like, you know, is it open source or not? What is the like business model is, and like, are they kind of actively, you know, engaging with issues related to user privacy? We'll talk a little bit more tomorrow about legislative issues around privacy, and that's also another way, like have they taken positions on particular, you know, proposed laws that could harm user privacy? Those are, to me, those are sort of like how are they kind of like acting on principles?
It also might be, oh, sorry.
Go ahead.
It also might be a good way of checking to see if they've produced blogs in court proceedings, so you know that they don't track traffic. Also, to see, like, say certain companies might be funded by other companies that like are less concerned about public safety or privacy or human rights. So that might also be a good way of like checking to see like the integrity of a VPN company. So at the end of the day, they're all companies.
All right. The next question: would y'all consider WordPress reputable for housing a sex worker website? Thank you for asking this, because it lets us kind of talk about something I wanted to figure out how to include in that full presentation, but didn't. Just as like a point of clarification, and maybe this is understood by people, but maybe for the video it will be helpful. WordPress is both a like hosting company and a piece of software. WordPress, I think it's wordpress.org is the hosting one, or is it wordpress.com? I can't remember. I think it's wordpress.com. But you can host a website on WordPress's like platform, and when you do that, you will be like running a website that is built using WordPress's software, which is also called WordPress. This is confusing and annoying. But you can also use WordPress's software on another like hosting service. Like you can install WordPress onto a like hosting service website. I think a fair amount today, like of hosting services actually do sort of a one-step click, like they'll set up a server with WordPress for you option. In terms of WordPress, like as the host of a website, and as a host for sex worker websites, I don't actually know. I would say I would like check I would need to go check their terms of service. I think in general, yeah, I don't totally. I think with all hosting companies, it's like they're like figuring out which ones are kind of the most reputable is partly about looking at any past incidents they've had in terms of takedowns, or or like what they're also like where they're located. So like WordPress is a company based in the United States, so they're beholden to United States laws and regulations. I'm guessing part of the reason this question was asked is that this person, that you probably know a little bit about FOSTA SESTA, which makes it harder for companies to allow any content related to sex work on their servers. And as far as I know, WordPress wants to be compliant with it and hasn't taken a radical stance against it. Blunt, do you have any?
Yeah, I can say, I think hosting anywhere on a US-based company right now has a certain amount of risk, which you can decide if that works for you or not. If you are hosting on WordPress right now, I would just recommend making lots of backups of everything as like a harm reduction tool. So if they decide to stop hosting your content, you don't lose everything. And I also just recommend that for most platforms that you're working on. Cool. So we have around 15 minutes left. So if there are any other questions, now's the time to ask them. And if not, I wonder if just chatting Ingrid and Olivia a little bit about what y'all will be covering in the next 2 days. Okay, we have 2 more questions. This may be a digital surveillance question, but once you get a browser fingerprinted, is it reversible?
Okay. That's actually a question where I'm not sure I know the answer. Olivia, do you have any of that or no?
No.
I do know that you can sort of, I know on like depend that on mobile devices, you can like spoof aspects of your identity. Like you can so I mentioned MAC addresses as sort of this like hard coded thing. Like that's just the idea of your like device. A phone can actually you can actually generate sort of like fake MAC addresses that are the one that's presented to the world. So if that sort of was a piece of your fingerprinted identity, that's one way to kind of like, it's like you won't be a perfect match anymore. But yeah, I don't know if there's sort of a way to completely undo a fingerprinting. Yeah, I will also look into that and see if I can give you an answer tomorrow if you're going to be here tomorrow. If you're not, it will be in the video for tomorrow. Thanks.
Great, thank you. And someone asks, are there any readings that y'all would recommend? I've read Algorithms of Oppression and I'm looking for more. I love this question.
The minute I heard that question, like a really long list of readings just like ran through my brain and then deleted itself. We'll definitely share like a short reading list in the bibliography that we'll send out later.
Awesome, that's great.
Yeah.
Okay, cool. This has been really amazing. Thank you so much. I'm just going to say one more chance for questions before we begin to wrap up. Or also, I suppose, things that you're interested in for the next 2 days to see if we're on track for that. Someone asks, this is a fintech related question for digital surveillance, but can you talk about that, how that kind of works internet wise?
Fintech.
For financial technologies.
Like
and how they track you. Oh, so like if you're using the same email address for different things, is that sort of on the?
Or is it how
of tracking, like bank tracking, like money type of?
Okay, so I think there's like a very tiny bit about this in tomorrow's stuff, but I think like in terms of how like I'm gonna probably get this a little bit wrong, or I want to make sure I say this clearly. So depending on the like financial servicer like you're working with, like PayPal or Stripe or whatever, they're going to have they like, in order to work with banks and credit card companies, they're sort of expected to kind of know things about you. These are like related to rules that are called KYC, know your customer. And so part of like the tracking, or like what we're not tracking, but part of information that is like collected by those providers is a matter of like them being legally compliant. That doesn't mean that it produces great results. It's simply true. And I think in terms of the layer, I'm trying to think of like I don't know as much about whether or not companies like Venmo or Stripe or PayPal are sharing transaction data. I'm pretty sure that's illegal, but who can say? Lots of crimes happen now. We live in capitalism.
I also just dropped the account shutdown harm reduction guide that Ingrid and Hacking Hustling worked on last year, which focuses a lot on financial technologies and the way that like data is sort of traced between them and potentially your escorting website. So that was just dropped into the chat below, and I can tweet that out as well in a little bit.
Privacy security issues, Zoom versus Jitsi. I also prefer to use Jitsi when feasible, but I've also found that call quality kind of drops like really harshly the more people log on. Like I don't think we could actually sustainably have a call of this many people on Jitsi without using like without hosting Jitsi on another server. Concerning how I handle the privacy security issues of Zoom, they're saying that like they're gonna start baiting end-to-end encryption like later this month. I don't actually know like what that even means for them, considering that they're not open source, right? But I do say that one of the things that I tend to try and practice when it comes to like using Zoom is kind of maintaining a security culture amongst me and the people who we're talking to, right? So I'm never going to talk about like any direct actions, right, that are going to happen in real life on Zoom. Refrain from just like discussing activity that could get other people in trouble anyway. Like while it would be nice to have like say this kind of conversation that we're all having now over an encrypted channel, I think it's generally much safer. And I don't like using the word innocent, but that's like the word that is popping into my head to talk about, to use Zoom for education, even if it is security education, than it would be to actually discuss real plans. So it might be really beneficial to you if you are like say using Zoom to talk to a large group of people about something that's kind of confidential, to talk over like Signal in a group chat or some other encrypted group chat platform, and decide like, okay, like what are you allowed to say over Zoom and what you're not allowed to say, and to think of Zoom as basically you having a conversation in public, right? Assume for all of your like Zoom meetings that someone's recording and posting it to YouTube later, and that would probably be the most secure way to use it in general, to just assume that all of your conversations are public.
Yeah, I totally agree, Olivia. And that's why also this is going to be a public facing document. So Zoom felt okay for us for that.
Yeah, I mean, another way I've thought about this with Zoom is like just remembering what Zoom's actually designed for, which is workplace surveillance, right? It's like, its primary market, like when it was first created and still is corporations, right? So there's lots of, so like also even when you're going into like, even if you're going to a, public Zoom thing that is, about learning something, like whoever is managing that Zoom call gets a copy of all of the chats, right? And even if you're chatting like privately with one other person in that Zoom, that message is stored by like someone gets access to that. And keeping that, mostly just that's something to like just keep in mind with, what you do and don't say, like especially if like you are not the person who is running the call. Think about what you would or wouldn't want someone you don't know to kind of like have about you.
Awesome, thank you so much. Do you want to start to wrap up and maybe chat briefly about what we'll be seeing in the next 2 sessions?
Sure, yeah. So the next 2 sessions are going to be one talking more about how platforms work, and sort of the whole like algorithmic curation, and how misinformation spreads on platforms, and really talking about security from like more of a like Instagram, Twitter sphere, rather than just thinking about like using the internet in general. And then the third will be talking explicitly more about like internet surveillance. So we're going to be talking a bit about surveillance capitalism, as well as like state surveillance, and the places where those intersect, in the places where you might be in danger, and how to mitigate risk in that way. If anything Ingrid wants to speak on that.
I think those are all of, that's the whole, you summarized it great.
Awesome. Okay, thank you so much, everyone. Excited for tomorrow and then Friday. I'm gonna go ahead and end the recording real quick.